Today we're going to be practicing finding some restrictions on your domain. In some cases where you have fractions, radicals, and a combination of them. So let's take a look at what we do when we have any sort of fraction. So any sort of rational expression. So in your denominator, and we can have lots and lots of different variations as you can see, but in your denominator, what number are we never allowed? So we're not going to be allowed to be equal to 0 because it's not divisible by 0. So that will cause an undefined solution. So in our first case, 0, x can be any number except for 0. How you write that on a number line is just an open circle, and then we can go on either end of your number line. So we can go from negative infinity to 0. We're going to jump right over 0 and then go on the other side. So union from 0 to infinity. So x can be super, super small, super, super big, positive, negative. It just cannot be equal to 0. And anytime we have these denominators of these values, these are going to be your vertical asymptotes. Or if you have anything that cancels out, we're going to have any sort of whole. So let's take a look at number 3. So numerator, there's nothing much going on in your numerator other than we just have an 8. So looking at the below, we're trying to figure out what number will cause your denominator to go or be equal to 0. So we're going to say 3x plus 9 is equal to 0, and we don't want it to be equal to 0. And we're going to treat it as you would any sort of linear problem. So we can subtract the 9. 3x is equal to negative 9, divide by 3. So x is equal to negative 3. Now we don't want that to happen. So we don't want x equal to be negative 3. So if we plug in a negative 3 into your equation, we get 0 or 9, negative 9 plus 9 to be then 0. This is what we don't want to happen. So on your number line, as far as your domain goes, negative 3 is the number to avoid. So we're going to go on either side of your domain, either side of negative 3, I should say. And so we're going to go from negative infinity all the way to 3. We're going to jump over 3, and then we're going to, or negative 3, and then we're going to continue. So let's try it again with number 2. So pause the video and try number 2. So again, we're trying to figure out what number x we should avoid. So x minus 2 is equal to 0. We can add 2 to both sides. So x is positive 2. Again, we don't want this to happen because if we have 2 in your denominator, that will make it a 0, which again, we do not want. So x can be any number in your domain other than 2. So we go from negative infinity to 2, union to infinity. Now, what happens when your denominator looks a little different, like this one? Well, in your denominator, we have now a polynomial. In your numerator, we then just have 6x. So we definitely want to recognize, can this be factorable? When you see polynomials, we want to factor. Your numerator, we can leave alone because that is as simple as we get. Now, if you don't know how to factor, please look at the other videos on how to factor. So we're looking at factors of 12 that can get us to 7, which are 3 and 4. As long as we add them together, we can get positive 7. And when we multiply them together, we get 12 still. So we have x plus 3 and x plus 4 and 6x. Now you'll notice that nothing is going to cancel to cause a whole. However, we still have no equal to 0. So we're going to take what we have in your polynomial, x plus 3, and we can still set it equal to 0. So subtracting 3 from both sides, x is equal to negative 3. So this is one case that will cause a 0 if we insert it back into the formula. Negative 3 plus 3 is 0. So 0 times 4 or negative 3 plus 4, and that'll be a 0 down below. We do it again for the other side. X plus 4 is equal to 0. Subtract 4 to the other side. Now x is equal to negative 4. Again, another number that we want to avoid because it will result in a 0. So we have two numbers now that we need to avoid. Negative 4 and negative 3. Open circle, we don't want to be at these values. And we can be any number between them and past them. So negative infinity to infinity. Now we're going to start to put these in chunks. So we're going to go from negative infinity all the way to 4 and jump over 4. Negative infinity to negative 4 and jump. Then from negative 4 to 3, negative 4 to negative 3, and then we're going to jump over negative 3 and go to infinity. Now try it again with number 4. So we're looking at your denominator being factorable. So 8 and 12 can get you to 96 with a negative 12 and a positive 8. So x plus 8 and x minus 12. And meanwhile, in your numerator, we have x cubed. Now, x cubed as its own graph is just the one that looks like an S curve. And now we have these two values that we need to avoid. Now, because there's no cancellation, we won't be able to simplify. So we want to set these both equal to 0 to avoid your 0. So x plus 8 is equal to 0. So x is equal to negative 8. This is one number we want to avoid. Doing it again is equal to 0. We want to avoid 12. So x is equal to 12. So these are now the two numbers that we want to avoid. Negative 8 and 12. And we're going to jump over these two values. So see if you can write your domain here. Now let's take a look at number 6. So for number 6, we're trying to figure out if it is factorable, both the top and the bottom. Now we want to also factor the top because we're looking to see if there's any sort of holes that we need to account for as well. Because all of these that do not have any sort of cancellations, these are just your vertical asymptotes. So in your numerator, when we go to factor it out, we're left with 3x minus 8. So now let's take a look at your denominator. So your denominator, when we go to factor, we're looking at factors of 2 and negative 3 to make negative 6. So factors of negative 6 that can get you to a negative 5, but keeping the negative 6 is 1 and 6, negative 6, positive 1. And when we go to multiply them back together, you are still working with a negative 6. So these are your factors. So figuring out 2x plus 1, x minus 6x minus 3. So looking at factor of grouping, we have 2x plus 1. And again, over here, taking out a negative 3, you're left with 2x plus 1. So we get x minus 3 and 2x plus 1. So x minus 3 and 2x plus 1. So unfortunately, again, nothing is going to cancel out. The only time we can cancel is when your parentheses are the exact same, in which case there's nothing that can cancel. So we're left with two vertical asymptotes, which means your numerator provides no restrictions. These are actually going to be your x-intercepts, but the denominator is going to be your vertical asymptotes. So we'll set these both equal to 0 and solve. X is equal to 3. 2x is equal to negative 1. X is equal to negative 1/2. These are the two values that we want to avoid in the future. So we'll put them on our number line, -1/2 and 3. We're going to jump over these values and go ahead and try to write your domain here. Right. So hopefully we did all right when it comes to your domain. So this is how we can do domain when it comes to any sort of rational exponent. So if you, or sorry, rational expressions. So this is when you have sort of fractions. Now let's take a look at what happens when you have radicals. Now with your radicals, oh, and I should say before we do your radicals, graphically, right, this variation, its parent graph, tends to look like this here, where your domain of your graph, and this is f of x is equal to 1 over x. So your domain here, if we're looking at just your domain values, we can see that we're going from -infinity and we're approaching where x is equal to 0, and we jump over this mark because this is where we have horizontal or a vertical asymptote. So we have a vertical asymptote when x is equal to 0. And then we're going to continue to go towards positive infinity. So that's how we're going to be reading these domains. We're taking this small number line and we're actually using it in our bigger picture. So similarly with your radical expressions, if we were to graph your radical, let's just say we have a very simple parent function. So this is our graph of f of x is equal to the square root of x. So this is just, to get your parent graph, we can just graph a few values. So when x is 0, the square root of 0 is 0. When x is 1, the square root of 1 is 1. When x is 4, the square root of 4 is 2. So we can plot those graphs. Now, if we go anything below 0, let's say we chose to do -1, are we allowed a -1 underneath the square root? No, this will produce a non-real number. And you'll notice that on your graph, there are no negatives allowed in the underneath the square root because you don't have negative x values. So your smallest value is at 0, and then we're going up. So then we can have positives. Now, how we say that in the mathematical sense, we can just say, okay, well, for x values that are greater than or equal to 0, you can be 0 under a square root. You can then go upwards from there. We just cannot be anything lower than 0. So we're going to be using this expression, greater than or equal to 0, for a lot of your terms. And if we were to write this in the interval form, we can say we're including 0 and we're going towards positive infinity. So again, taking this number line, going from 0, starting at 0, solid circle, solid closed circle, all the way up towards infinity. So let's take that fact. So we're trying to make it so that we don't see any negatives underneath the square root. But keep in mind, zeros are okay. So by setting this radical greater than or equal to 0, we then get to pull out your expression or pull out anything under the radical that could cause the negative sign. So with that, we can just add 3 to the other side as we did before. So now we have x is greater than or equal to 3. So on your number line, if we have 3 here, since we're greater than or equal to, the equal to meaning we are a closed circle, we then can go to the values that are greater than 3, which would be 4, 5, 6, all the way up towards positive infinity. So when we go to write your domain, we're in a bracket with a 3 towards infinity. Infinities will always have a parentheses around them because it's not achievable. We can't end and start on these infinity values. Now, if you did want to test it out, we can just put in a 3 for x. So we can do 3 minus 3 underneath the square root, which is equal to 0. 0 is okay. Anything less than 3, so let's say 2. So 2 minus 3 is equal to the square root of negative 1, which is not a real solution. Whereas if you picked anything above 3, so let's say a 4, we would get the square root of 1, which is 1. So again, a good response. So your threshold value here is when we are at 3. Because we are, in effect, are moving your graph around. We're moving this graph around and changing the behavior of it. So that's why we have new variations. So let's try it again with 8. So with 8, or yeah, number 8, we're going to set it greater than or equal to 0. Greater than or equal to 0. We subtract 8 to both sides. 2x is greater than or equal to negative 8 and divide by 2. So x is greater than or equal to negative 4. So your threshold value here is negative 4. Closed circle going upward. So we're greater than or equal to 4. So this arrow pointing where we want to go. So your domain is negative 4 to infinity. And again, I'll test it one more time to show you guys the proof of it. So let's test negative 4. So 2 times negative 4 plus 8 under the square root will produce negative 8 plus 8, which is the square root of 0 or 0. If we chose, let's say, negative 5, we have 2 times negative 5 plus 8. So negative 10 plus 8 is the square root of negative 2, not real. Which means anything higher than 4, negative 4 and itself will produce positive numbers. Now let's see what happens with the variations like 9, 10, and 11. So in this case, if we have x squared minus 9 is greater than or equal to 0, there's 2 ways we can do this. We can solve it as you normally would. Greater than or equal to 0. X is greater than or equal to 9, or x squared is greater than or equal to 9. And to undo a square, we now need to square root it. Now, when you make your own square root sign, you do have to account for the positive, for both plus minus, because you're going from a square term, one that could have 2 solutions, 2 x-intercepts, to now a singular one solution or 1 x-intercept. So you do need to account for both the positive and the negative possible solution. Now, if you're a forgetful person, I don't recommend doing it this way. So then you have the square root of positive or negative, or sorry, plus or minus the square root of 9, which then is plus or minus 3. Now, if this is hard to read, which they are, some of them are really, really difficult, we're just finding your threshold value. So we're going to throw these on a number line. Now, because we are greater than or equals to, we are going to be a closed circle at these particular points, which means if we put in negative 3 or 3 into your square root sign, negative 3 squared minus 9 is 9 minus 9, or the square root of 0, which is 0. So this is okay. Same is true over here. Doesn't matter because it's squared. So this is okay. So now what we need to do is we need to test on either side of these numbers. So on either side of these numbers, we can just pick a value. So in the middle, let's pick an easy one, 0. The square root of 0 squared minus 9 will produce a negative 9, which again is not real. So this part of it, the in-between portion, is not okay, which perhaps means that the outside portions will be. So let's go ahead and test. So let's do 4. 4 squared minus 9, which is 16 minus 9, which is 7. So 7 being positive, that's okay. And because this is squared, it is going to be symmetrical. So let's do -4 squared minus 9. We still get 16 minus 9, or the square root of 7. Again, a positive number, so that is okay. So on your number line, how can we write your domain? Because it's okay over here and okay over here. So you go from -infinity to -3, bracket, union. We have to skip all of the numbers in between, and then bracket from 3 to infinity. Now, before we jump right into our next one, we do have to be aware of some of your rules when it comes to negative, negative, what are these signs? Just negative signs that are attached to your x values. So we can still do the same, and I'll go back and I'll show you a different way to solve them. With factoring, we can do 1 minus x squared is greater than or equal to 0. So subtracting your 1, negative x squared greater than or equal to -1. And then because there's a negative attached to your variable, when you go to divide out or multiply out by that negative and it cancels, what we now have to do is switch your sign. So if it was a greater than or equal to sign, we're now as a less than or equal to sign. So we switch it anytime you multiply or divide by a negative. Now to take care of the squared sign, we now need to square both sides. If you make your own square root sign, we now have to account for both positive and negative answers. So we have x is less than or equal to positive or -1, because the square root of 1 is itself. So then you have both answers. So one more time, let's find your threshold value. You have a -1 here, you have +1. You can be equal to in these cases. So let's pick a number in between and let's test it. So let's do 1 minus the square of 0 under a square root. So we're left with 1, which is 1. So that means inside is okay, which likely means that the outside values are not okay. So let's test it again. Let's do 2. So the square root of 1 minus 2 squared is 1 minus 4, which will produce a -3. Same thing if you produce, or if you choose a -2, that'll still come out with a -4. So again, a -3, which is not okay. So when we go to shade, we're just shading between these two values. So your domain, -1 to 1. Now, why don't you try it again with 4, and then I'm going to show you what we can also do as far as factoring goes with 12. So let's take a look here. So again, setting it greater than or equal to 0, we can have 4 minus x squared is greater than or equal to 0. Subtract the 4. Divide by your negative. Switch your sign. And take the square root. So you're now positive or -2. So again, finding the threshold area, -2 and 2, picking a number. Usually 0 is a nice go-to. It's just a little bit quicker. So 4 minus 0 squared is just 4, or the square root of 4, which is 2. So inside so far is okay. And if you pick a value on the outside, let's pick 3. Or if you want -3, again, because it's squared, even if you pick negatives, it's still going to come out with the same response. They are symmetrical. 4 minus 3 squared, 4 minus 9, with a -5. So this one will also produce -5. So not okay here on the outside, which means on the inside, it's okay. Okay. So now we have that. Now let's go ahead and look at 12. So 12, we can use the same exact method with 10, 9, and 11. We can instead factor. So keep in mind, we can still factor. So let's take a look. Let's use factoring methods. So saying greater than or equal to 0, we can still have x squared plus x minus 12 is greater than or equal to 0. Now, you might be tempted to move this negative 12 over, but then that's going to be incredibly hard and it can produce incorrect responses. So instead, let's go ahead and factor. We can do x plus 4 and x minus 3 is greater than or equal to 0. Now, typically when we do your solving methods, we set x plus 4 equal to 0 and x minus 3 equals 0. Now, we can do this because we are, in fact, also equal to 0. So in this case, we have x is equal to negative 4 and x is equal to 3. Now, these, just as last time, are going to be your threshold values. So we have negative 4, we have 3 over here, and we are equal to these values. So let's go ahead, as we've done before, let's go ahead and test some numbers. So if we have 0 squared plus 0 minus 12 under a square root, you're left with negative 12. Again, not okay. So inside is not okay, which means on the outside, most likely it is okay. So let's test something other than 3. Let's test 4, or let's test negative 5. So we have negative 5 squared plus 5 minus 12. Plus a negative 5. So we get 25 minus 17. 17 is coming from negative 5 plus 12, or minus 12. So you're left with then a positive response. So this is okay. And doing it again over here, 4 squared plus 4 minus 12, 16 16 minus 8 is then just 8, right? Again, a positive solution underneath the square root. So these parts are okay. It's just the in-between section that's not okay. So your domain, we're going from negative infinity to negative 4, union 3 to infinity. Again, we are equal to these values, so that's why you're seeing a closed dot. Now we can do the same exact thing if we wanted to over here to factor. These are a difference of squares, so we get x plus 3 and x minus 3 is greater than or equal to 0, in which case you're just testing when x is equal to 3 and negative 3. If you're working with the below, before you start to factor, what we want to do is rewrite it to show that it is a difference of squares. Notice that we have a negative leading coefficient. We always want to factor out the negative before we get started. So you'll see there we have a negative on the outside, and that's just going to stay with us on the outside. So you get x plus 2, x minus 2 is greater than or equal to 0. So then, as we did before, we can set these equal to positive or negative 2 and then test. And you'll notice that by testing, you still have those threshold marks. Try the same with factoring with number 10. So you have 1 minus x squared is greater than or equal to x. Negative x squared plus 1 is greater than or equal to x. Factoring out that negative, switching that sign, and then factoring with the difference of squares. If we don't know how to factor with difference of squares, please see the factoring lecture or the video. And when you go to set it equal to these values, if you do have the negative on the outside, that's not going to make a difference because it's just a GCF of a numerical value. There's no GCF that you took out. Now let's make a combination of these two. So let's look at fractions and radicals together underneath your, so looking at them together, so finding a radical underneath the square root. Now in our case, let's say we have something a little bit easier, 1 over the square root of x. So we're bridging that gap, right? Underneath your, in your denominator, we cannot be equal to 0. And with your square root sign, we have to be greater than or equal to 0. But with the square root sign being underneath the denominator, we are not able to be equal to 0 anymore. So we're bringing these two ideas together to then just say we're greater than 0, or x is greater than 0. So we should have the idea of 0 to infinity non-inclusive. So let's start again with the below. So we're setting this greater than 0 as we've done before. 2x minus 10 is greater than 0. We can add 10 to both sides. 2x is greater than 10. Divide by 2. X is greater than 5. So this just means when we put it on your number line, because we are no longer equal to 5, but we have to be the numbers that are greater than 5, we now have that open circle again. And the values that are greater than 5 are off to the right. We're going towards positive infinity. So we're doing 5, comma, infinity with parentheses. And again, we can test that this is true. 2 times 5 minus 10 under a square root and under in the denominator. So you have 5 over the square root of 10 minus 10, which is 5 over the square root of 0, or 5 over 0. So this is not okay. So anything 5 and below is going to be considered 0 in the denominator, which we are not allowed. Let's have you try that again over here. And the same rules apply. If you would rather factor, that's quite all right. So greater than 0, we can set x squared minus 144 to be greater than 0. So we want to say, so we can do it two ways. X squared is greater than 144, which then just means when we take the square root, we're both positive or negative 12. Now, because we are not able to be equal to these values, we are going to be skipping over negative 12 and 12. And again, we're going to start to test these values. So we're going to have open circles here. Let's test an easy number on the inside. So if you have 0 squared minus 144 underneath that square root, you're left with that negative square root of 144, which is not okay. If we put in, let's say, a negative 12 underneath the square root, 144, this will produce 144 minus 144, or the square root of 0 is 0. But keep in mind, this is this is over 9. So 9 over 0 is not okay. So that's why we have open circles here, which means if we test these outer numbers, these parts will be okay. So we're going to go from negative infinity to negative 12, and then 12 to infinity. Let's do it again here with 15. So pause the video and see what you come up with. Now this one, I'm going to use those factoring methods. So we have x squared minus 100 is greater than 0. With the difference of squares, we can say x is minus 10 and x is plus 10, greater than 0. So x, we don't want to be equal to 10 and negative 10. And we want to figure out, well, where does that threshold value lie? So let's do negative 10 here and 10 over here. We have to be open because we are greater than 0. If we put in a 10, we're going to be bigger. And even better, if we plug in a 0 into your value, 0 squared minus 100 will then be a negative 100, which is, again, not okay. So we're going to be shading on either side once more. So we're going from negative infinity to negative 10, union, 10 to infinity. Let's take a look at a few more variations. So let's look at y. So now notice that we have multiple things going on. We have a denominator, we have your radical. So let's take a look at your numerator. So in your numerator, we have the square root of x squared minus 36. How would you tackle this problem? We set it greater than or equal to 0 because we're located in the numerator. Zeros are okay. So x squared minus 36 is greater than or equal to 0. So x, I'll do it this way, x minus 6, x plus 6 is greater than or equal to 0. So x can be negative 6 and positive 6. So I reversed those, I'm so sorry. So we can go ahead and test those numerical values if we want. And then taking a look at your denominator, we have 2x minus 8. How would you approach this one? Well, in your denominator, we just can't be 0. So we're looking at 2x is equal to 8. So x is equal to positive 4 when you divide by 2. So we don't want this to happen. So x, we need to avoid negative 4. Why do I keep doing negative? We need to avoid positive 4. So we know positive 4, we have to skip. Now let's take a look at what happens with 6 and negative 6. So with negative 6, we are able to be at these values. And keep in mind, 4 is somewhere over here, so we don't want to pick 4. So let's go ahead and pick, let's just pick 0. So 0 squared minus 36 is then negative 36 underneath that square root. So then that's not okay. And that'll happen for any values that you choose inside here, which means on the outside, we can be any value. So your domain here, while negative 6 and 6 are all right, and while negative 4, we definitely want to jump, any value in here will cause a negative response. You could put negative 5 in here, and we're still left with negative 25 squared minus 36. So not negative 5. Can't say that today. So let's say we chose, for example, negative 5. Negative 5 squared minus 36 is then 25 minus 36, which will produce that negative even though, and don't forget there's a denominator, it'll have an issue with the numerator even if the denominator is okay. It just means that any value that you're choosing between these ones will not work, which means that we're looking at either side. So from negative infinity to negative 6, union 6 to infinity. And we can still include these 6 values because you still are able to have a 0 in your numerator. And even if you do positive or negative 6, it's not going to produce a 0. Let's have you try that again with 17. So with 17, your numerator, we have x squared minus 25 is greater than or equal to 0. So we have x plus 5 and x minus 5, which is greater than or equal to 0. So we're looking at negative 5 and 5 as some threshold values. In your denominator, we have 3x minus 24 is equal to 0. 3x is equal to 24. So x is equal to 8. Now these are numbers that we want to avoid. So we want to avoid 8 for sure. We also have some other values to test as well. So we have 5. So sorry, we have 5, 8, and negative 5. So let's go ahead and test 0. That's always a go-to, and we can be equal to these values here for now. So let's say, oh, and we got to jump 8. So 0 squared minus 25 over 3 times 0 minus 24 causes an issue in your numerator. So not okay anywhere in between. Whereas if you pick something on the outside, that will be all right. Now let's test something over here. Let's test 6. So 6 squared minus 25 under square root over 3 times 6 minus 24. That won't cause an issue down below, so that's okay. And up here we have 36 minus 25, which will come out positive. So 6 is okay. So that means numbers from 5 to 8 are okay. Now, if we put in an 8, though, let's say we have 8 squared minus 25 over 3 times 8 minus 24. So 64 minus 25 under the square root, it's going to be positive. That's okay. But down below, we get 24 minus 24, which is going to cause a 0 down below. That means that number is not okay. So when we go to write your domain, we then have to skip these values. So we're going to go from 5 to 8, and then from 8 on. And same thing down below over here. So we have negative infinity to negative 5, union 5 to 8, and from 8 to infinity. And there we go. So if you need some more practice, here you go. Just state the domain and interval notation. So there's just some extra stuff.